Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Before starting with this topic, let us first understand the meaning of the word acquisition. Acquisition means that we are acquiring or collecting something from the nature. Okay? Acquisition is collecting something. So data acquisition means collecting the data from the real world or the physical world and then converting that data into the signals which can be processed by the computer. So data acquisition system, they are those systems which collect the data and convert those data into some signals, do some processing over those signals, and those signals are then processed by the computer for the use of the engineers. Okay. So data acquisition system is defined as an information system which collects, stores and distributes the information. So that is the acquisition of that data. Okay. Now these systems are used in the industrial and the electronic engineering field. So in that it is used to capture the electrical signals, and those electrical signals are converted into other form of signals and then they are processed by the computer, so that in future if we want to use those signals, that can be done with the help of computers. So these data acquisition systems, they find their application in the industrial and the commercial electronics, where they are used to capture the electrical signals from the physical world. Okay, they can be used to capture in electrical signals or the environmental conditions. So from the physical world we are getting the signals, and these signals are then stored in a computer device, so that processing can be done into it and they can be used for the future use. So because it is doing the work of capturing, converting and storing, so the various components of the data acquisition system, their objective is to accumulate the data and do processing over that. So these data acquisition system, which are also called DAS or DAQ, it is the short form of the data acquisition system. So these systems, because they are collecting, storing and processing the data, so they include different tools and technologies which are designed to accumulate the data. Okay. Now let's see that what are the various components of a data acquisition system. So a typical data acquisition system, it consists of a sensor, then it consists of a signal conditioning equipments, a data conversion unit, data processing, multiplexing, data handling, because the work of data acquisition system involves first acquiring the data, then do the processing over it, storing that data, and then transmitting that data. So for the capturing of the data, it is having the sensor. For processing over that data, it is having signal conditioning, data conversion, data processing, multiplexing, data handling units. Okay, these are all handling the data, doing the processing over it. Okay, after that, for the storage, for the display, for the transmission of the data, we are having different devices for associated transmission, storage, and the display devices. So we can broadly say that the data acquisition unit, it consists of these separate or the individual units, and the function of these units is to first acquiring the data, then doing the processing over it, and then its transmission or its storage or display. So now, based on these units, we have broadly seen that what are the individual units which are to be included in the data acquisition system. Let's see the block diagram of a DAS. So this is the block diagram of the data acquisition system. You can see that the main units, the subunits which we have studied earlier, these subunits are combined to form a bigger unit. So as we have seen that because this data acquisition system, it is first acquiring the signals from the physical world. So there are various transducers here. These transducers are collecting the data, because that data is in the non-electrical form, so that is converted into an electrical form by the transducer, so that electrical signals can be used by the other stages of the system. Now after that data, which is converted into an electrical signal like voltage, current, resistance, in that form, in the electrical form, that data is going to be processed. Those electrical signals will be processed, like if there is any noise or any unwanted signals are there, so those signals will be filtered out. Okay, so signal conditioning is done there. After doing signal conditioning, we are having the multiplexer, that which electrical signal we want to choose. So according to that, because different electrical signals are given to the system, so multiplexing is done, that which electrical signal we want to use for the further stages. Then either that data is converted into the digital form, or if we want the analog form of the data, then analog data is also used. So then conversion is done, either analog to data conversion or directly the analog data is used. Now after doing the conversion, the data is transmitted, it is displayed, or it is either stored. Okay, so display devices are also there and storage devices are also there. So storage devices are used so that the signal can be used for the future use, and display devices, if we want the direct display of that data, then display devices can also be used. So for analog data also, the display and transmission and storage is there, and for the digital data also, the display, storage and transmission is there, like it can be transmitted to some other system also. So these are the main components of a data acquisition system. Let us study the function of these units separately. So the first component of the data acquisition system was a transducer. So what a transducer does, it converts the physical quantity into an electrical quantity. So transducer, it can be used to convert the physical quantity into the electrical signal, or it can be used to directly measure the electrical signals. Electrical signals like voltage, current, frequency, resistance, all these are the electrical quantities. So we can have a transducer, or we can also say that it is the sensor. Sensor is going to measure directly the electrical quantity, and transducer is converting the physical quantity into the electrical quantity. So that is the first component of the data acquisition system, which is acquiring the data from the physical world or the environment. Okay. Next component is the signal conditioner. Or we can say the signal conditioning unit. Now the signals which are coming out of the transducer, they are the electrical signals, but they are very weak signals, means they are having very low amplitude. So to increase their amplitude, amplification has to be done. Also, if the signal is containing any unwanted signal or noise is there, so to remove those noise and to remove the unwanted signal, either rectification or filtration of those signals is being done. So all that is done in the signal conditioning unit. Okay. So as the output signals of the transducer is very weak signal, very low signal is there. So this weak signal cannot be used for further processing or for the further stages in the data acquisition system. So first the conditioning is to be done. So to make these signals strong, various signal conditioners are used. And these signal conditioners can be like, if we want to amplify the signal, then we are having amplifiers. If we want to filter the signal, means if we want to remove the noise, then filters are used. If we want to modify the signal, then modifiers are used. So depending upon that what type of signal we want for the other stages, depending upon them, the processing over the signal is being done and the element is used. Okay. Now after signal conditioning, we are having the multiplexer and the A to D converter. First we are having the multiplexer. So what's the function of multiplexer? Multiplexer accepts many signals and it gives only a single output. So multiplexer is going to mix all the signals and the according to the need of the system, it is going to generate the output signal. So multiplexer, it accepts multiple analog inputs and provide a single output signal. According to the requirements of the system. So you can see in the diagram also, there also we were having from the signal conditioner various analog input analog signals are coming. Multiplexer is accepting those signals and it is providing only a single output signal. After multiplexer, we are having the A to D converter. The A to D converter, it converts the analog data into the digital data, because in many electronic systems only the digital data is being used. Okay, because the transmission of digital data is very fast, also its processing is very fast. So in most of the areas only digital form of signal is used. So conversion becomes very important, and A to D converts the analog data into the digital data. So why this conversion of data is important? Because digital data, it is very easy to process, it is very easy to transmit, and the processing over digital data is very easy. So due to easy processing, easy transmission, and also digital display and storage is also easy. Because when digital data is stored, it is going to acquire less space. Also, if we are getting the digital readings, then also the errors are reduced. So in all these cases, the digital data is having more advantages than the analog data. So there is a need for converting the analog data into the digital form, which is done by A to D converter. After the conversion, just the transmission or the display or storage of data is needed. So for that purpose, we are having the recorders and the display devices. So this data is displayed in the display devices so that the input signals can be easily monitored. Now examples of display devices are oscilloscopes, numerical displays, panel meters are there. So there are different types of display devices, okay. Oscilloscopes, numerical displays, panel meters are there, which gives us the digital reading or digital output. Now recording can also be done, like if we want that at present we don't want to use the data or get its reading, we want to store it and keep it for the future use. So recording can also be done. So data can either be permanently or temporarily stored. So if we want to store the data, then storage devices can be used. If we want to record them, like recorders can be used for that purpose. So various elements are used. Examples of such are like optical recorders, ultraviolet recorders are there. Also there are stylus and ink recorders. So if we want to analyze that how the input signal is changing with the time, then recorders can be used. So these recorders, what they does that for a period of time, how the input signal is varying, what are the changes occurring in the input signal, that can be recorded. So signal will be recorded for a period of time. Now if we want that data is to be stored in a place, so we can use the storage devices, like disk can be used, okay. Printed magnetic tapes can be used for that purpose. Floppy disks can be used, okay. So in the disk and tapes, the data can be stored for the future purpose. So magnetic tapes and punch recorders and punch tapes, they can be used. So in the block diagram of the data acquisition system, we studied that the transducers, they are going to acquire the data, collect the data or capture it, then convert it into electrical signals. Those electrical signals will be processed or conditioned by the signal conditioning unit. Then multiplexer is going to accept all these analog signals and provide us a single output according to the requirements, that according to the requirement of the system, that which type of electrical signal we want. Now according to our need, that whether we want an analog output or digital output, then conversion is done, and for storage, transmission, and for the recording purpose, we can use different devices. So this was the block diagram of the data acquisition system. Now these data acquisition system, based on the type of output produced by them, they are divided into two types. One is the analog data acquisition system, another is the digital data acquisition system. Analog data acquisition system will give us the analog output, and digital data acquisition system will give the digital output. Now, come to the point where we will study the objectives of the data acquisition system, that for what purpose these systems are used. So first objective of the data acquisition system, or first requirement which we expect from the data acquisition system, is that it must acquire the necessary data and collect it. So like if we want that this type of electrical signal should be collected from the physical environment or physical world, then the data acquisition system, it must acquire that necessary signal only. So the system, it must acquire the necessary data at the correct speed. Second is now first acquiring is being done. Now after that, data should be efficiently handled so as to inform the operator about the state of the input, because this data, after acquiring, it has to be properly transmitted so that operator can get the correct data. Okay. Now also the data acquisition system, it should be able to monitor the complete plant operation, because it is involving different subunits, signal conditioner, transducer stages there, then multiplexing stages there, conversion stages there. So it is going to, it must monitor all the complete plant operations so that safe operations and optimum operations can be performed. Also, the data acquisition system must be able to summarize and store the data for diagnosis of operation and for the record purpose. When the last stage is done, that at the last stage, recording and storage of the data is done. So at that time, DAS must be able to summarize the data and store it properly, so that when the time of diagnosis of the data, it can be easily done, and for the record purpose also. Like when we are storing the data, all the data has to be accumulated correctly and stored properly, so that when diagnosis is done, data is not damaged and not incorrect data is available at that time. Now the data acquisition system, it must be able to expand so that for the future requirement, if in future we want that this stage should also be added in the system, so that can be easily done. So it must be flexible and capable of being expanded for the future requirement. Also, the data acquisition system must be reliable and not have a downtime greater than 0.1%. Reliable means that if we are using the system for a longer period of time, its performance is not degraded, its efficiency does not decreases. So it's a reliable that at every stage it is going to give us the accurate and correct measurements and correct data is available to us. So it must be reliable and it should not have a downtime greater than 0.1%. So the next objective is it must provide an effective human communication system, because the operator of the system is a human, so that human can easily understand the output and it is in the readable form. Okay, if it is in the machine form, then the human operator, they will not be able to understand it. So the system should be have an effective human communication system so that the operator can easily handle that system. Also, the other requirements of a data acquisition system involves that it should be very simple, it should be cost effective. Okay, so that it is having a minimum cost to the operator. Okay, so these are the different objectives of the data acquisition system which it should fulfill for its better use and for its better performance. Now comes the applications of the data acquisition system or its applications, we can say. Applications or uses of DAS. As we have studied that the data acquisition system, they are of two types, analog and digital, depending upon the type of output provided by them. So their applications is also different. Analog data acquisition system also have different application, digital also have different applications. So the analog data acquisition system, they are used in the applications where the physical quantity which we are monitoring through the system, that is having a wide frequency width. So when wide frequency width is required and when lower accuracies can be tolerated, means if we are having the system which is providing very low accuracy and the physical quantity is having a very wide frequency width, then we can use the analog data acquisition system. Whereas the digital data acquisition system, they are used when the physical quantity, it is having a very narrow bandwidth. Also, high accuracies are needed in the system and low per channel cost is required. So according to our requirement, the acquisition systems are used, digital or analog. Now, as these digital data acquisition system, they are more complex than the analog systems. So the digital data acquisition system, they are more complex than the analog systems, because both in terms of the instrumentation, the components, the various components which are used in these system, that is also more complex in digital systems. Also the volume and the complexity of the data which they are handling, that is also making the digital systems more complex. Volume is of data is also more, complexity of that data is also more. So digital systems are more complex than the analog systems. Now this was the difference between analog and digital, and on the basis of that difference their applications is also different. If we talk about together the application of the data acquisition system, then they are having industrial applications also, in industrial areas also, and in scientific areas also. Like in the aerospace they are used, in biomedical field they are used, in telemetry also they are used. Now in industrial areas, in the plants, they are used for capturing the data. Okay, and in scientific areas like in aerospace, biomedical and telemetry also they are used for capturing the or collecting the data. So it is having applications in the industrial field also and in the scientific field also. So this was all about the applications of the data acquisition system. So in this video, we studied about that what is a data acquisition system, what are the various components of data acquisition system. We saw it through its block diagram. We saw the functions of various components. Then we saw the types of data acquisition system. And in the last, we studied the applications of the data acquisition system along with the objectives of DAS. So I hope that this topic is now clear to you. Thank you.